I am Nikita Wagmare. Today I will presenting a very interesting topic from the field of machine learning, clustering and types helps machine find hidden patterns and group data without us telling them how to do it. Let's explore how it works, the different types and how it's used in real world. This presentation explores the fundamental concept of clustering and its deserved types, machine learning. Discover how these unsupervised techniques hidden patterns in data, impacting various real-world applications. Next one is, what is clustering? Clustering is nothing but unsupervised learning. Simple definition in clustering. Clustering is the process of grouping similar atoms or data points together so that atoms in the same group collected. It is called clustering, are more similar to each other than to those in other groups. Discover clustering. The goal is to find inheritance structure within data. Discover application used in customer segmentation, analog detection, and image analysis. Pattern identification. The algorithm identifies patterns and relationship automatically. Next one is partitioning clustering. It means k-means algorithm. In that divides the data into non-overlapping groups. It's clustering. You choose the number of cluster k before starting. Each data point belongs to only one cluster. It means you have cluster data, you divide them into 3 clusters: low senders, medium senders, and high senders. K-mediums algorithm uses actual data points as cluster center, more robust two outliers than K-means. Example, grouping documents by topic offer greater stability in discovered datasets. Next one is hierarchical clustering. In that, aggregative, division, and dendrogram. Aggregative, in that bottom up. Hierarchical clustering, in that this method builds a tree-like structure of clusters where small cluster merge into bigger ones. One big cluster is split into smaller ones. Aggregative bottom up. Start with individual data points as cluster, then merge iteratively. Example, grouping genes by expression level. Second one is a division, top down. Begins with one large cluster and iteratively split it into smaller ones. Example, segmenting a market into niches. Third one is dendrogram visualization. A tree diagram display the clustering hierarchy, show how clusters are formed and merged. Next is density based clustering. In that, this method finds dangerous area in data and groups them together. It greater for detecting cluster of any shapes and also find outer lights. It is used in real words, detecting geographical regions or social media communications. In that, DB scan algorithm identify clusters as dangerous regions separated by sparse areas. In subpoints, no predefined number of clusters needed, robust to outer layers and noise. Example, anomaly detection in network traffic. Second one is a optic algorithm, an extension of DB scan, creating a cluster ordering. Visualization, the density based structure, facilitate parameter selection, provides a details cluster hierarchy. Next one is a distribution based clustering. In that, Gaussian mixture model parameter estimation, biological data, expectation maximization, a Gaussian mixture in that assumed data is generated from a mixture of a distribution. Parameter estimation in that each cluster is a Gaussian parameter are estimated. Third one is a biological data. Example, identifying cell types in biological data sets. Fourth one is expectation maximization. EM algorithm iteratively estimate these parameters. Application of clustering. Application of clustering is the customer segmentation. Identifies group with similar behavior for dollar marketing. Second one is the image segmentation. Group pixel for object recognition and details image analysis. Animal detection. Flock unusual patterns in data for fraud or cybersecurity. Document clustering. Organize documents by content similarity for information retrieval. Final is conclusion. Powerful tool. Dis- Deserve algorithm. Contains pattern. Broad impact. Powerful tool in that clustering is a crucial for unsupervised learning and data exploration. Diverse algorithm. Key algorithms include k-means clustering, hierarchical, DB-scan, and GMM. Contains patterns. Algorithm choice depends on data, characteristics, and specific goal. Broad impact. Clustering has wide-ranging application across many domains. Clustering is a powerful unsupervised learning technique that helps in discovering patterns in data. We explored a different clustering method like k-means, hierarchical, and DB-scan, and saw how clustering is used in marketing, fraud detection, and recommendation system. Thank you for your attention.